Hey everybody, Matt Morgan here. In this lesson, we're going to talk about electron configurations from section 6.4 in OpenStax. We'll review the orbital information that we talked about last lesson, go through how to build the electron filling series, and then go through some examples getting the electron configuration of a few different elements. Here's our review. So find the missing part to the sequence of orbitals. I'll let you think about it for a minute, come up with an answer in your head. Here it is. It is the d orbital. The four types of orbitals are s, p, d, and f. Here's another question. How many electrons does it take to completely fill the second energy level? Hopefully you have an answer, and I get 8 electrons in the second energy level. Let's look at the chart that we posted at the last lesson. So a lot of information here, but if we focus on the second shell, it has the number of orbitals, the types of orbitals, and finally the maximum electrons in that shell are 8. 2 electrons in the s orbital, 6 electrons in the p. Now that seems like a lot of information, but you don't have to memorize all of it. The crib sheet that you get is the periodic table, and we will show you how you can get all the orbital information that you need on that periodic table. We talked about it a little bit at the end of the last lecture. We'll go through it more in depth now. So we've solved the Schrodinger equation, we've found the quantum numbers, and we've seen how the quantum numbers convert to the orbital information. So we went through all that because we want to know where electrons are located in the atoms, and more importantly, how they bond, which electrons participate in bonding, and what kind of bonds an atom makes. And all of this starts with knowing the orbitals and knowing where the electrons are located. So here's the electron filling series. So which orbitals fill first? We've got some rules based on what we've talked about so far. One rule is the Aufbau principle, and you don't have to memorize these names. You just have to apply it when you find the electron configuration. So the Aufbau principle says electrons will occupy the lowest energy orbitals first. So which orbitals have the lowest energy? There are a couple of ways to tell. So there's a diagonal diagram we'll show on the next slide. And then my favorite is the periodic table. You can use either one of those methods. So we also need to remember how many electrons fit in each of the subshells. So we're going to start with the diagonal diagram. This is in your textbook, and it's functional. It will work, but you will not be given this picture. So you either have to copy it on your 3x5 card or reproduce it from memory after the exam starts. But it does work. My choice is a periodic table because you get one. And last lecture we talked about where the s orbitals were, where the p orbitals were, where the d orbitals were. All of those locations are shown on the table, and you get one. Now, your table won't be labeled with the orbital designations, but that's okay. I think you don't need that if you've practiced a little bit. So you will be able to determine electron configurations, and we'll go through a couple of examples using the periodic table. Let's start with the electron configuration for silicon. The first thing we have to do is determine how many electrons it has. We look at the periodic table, and there's a lot of elements. There's silicon right there. The atomic number is 14. If it's the neutral silicon atom that we're talking about, and we are, it has 14 electrons. So we need to find homes for all 14 of those. Here we go. Our first orbital that fills is the 1s, and it holds 2 electrons. The 1s for hydrogen and helium. After the 1s, we go to the second row. The block on the left is the s block. 1s2, 2s2. The s orbital holds 2 electrons. After the 2s is the 2p. It holds 6 electrons. We're now up to 10. Silicon is 14, so we'll keep going. After the 2p, the 3s, 2 more electrons there. After the 3s is the 3p, and we don't need to fill that orbital. We're just going to 2 electrons in the 3p orbital. So our electron configuration: 1s2, 2s2, 2p6, 3s2, 3p2. Notice that all the electrons there add up to 14. Okay, we'll work one more. Cobalt. Look at the periodic table. We find out cobalt has 27 electrons. We'll build up just like we did for silicon, but 27 is bigger than 14, so we'll keep going. 1s2, 2s2, 2p6, 3s2, 3p6. After the 3p, 4s2, we're up to 20. Now we fill the 3d, 3d7. Even though we go from 4s to 3d, the first d orbital we encounter is the d, or is the 3d. So there's our electron configuration. The first d orbital you will encounter will be the 3d orbital, even though it's in the 4th row. So the periodic table was working so well until we encountered a transition metal. Remember what we said about transition metals. They are the rule breakers in chemistry. But if you just remember the first d orbital you encounter is the 3d, you will be fine. So we took this information, we learned about orbitals, and we used it to find electron configuration. There's a lot of practice in the homework, so go through and do those electron configurations. The more you practice, the easier it will get. And as always, if you have questions, there's my email. We have office hours Tuesdays and Thursday mornings, 9 to 10 a.m. Central Time. And you can always make an appointment if the office hour times do not work for you.